Welcome to this video. I'm going to show you how I architect my apps to be pretty simple, straightforward, using clean architecture. It's going to be very modular, and it's also going to set us up for success when we use AI to build our features and to ship our app. So I'm going to share like a high-level overview of how I architect my apps. I'm also going to share with you the core architecture that gets placed in each of these frameworks and how modular it is and how it can be used across different platforms such as iOS, watchOS, tvOS, visionOS, macOS, and any new platform or framework that Apple may come out with in the future. It's very modular in the sense that it can be drag and dropped into any ecosystem and it will still work. And that is one of the tenets behind clean architecture. So we'll go deep into that topic later. I'll also be sharing with you the app architecture. So how I build it within iOS today and showing you like a glimpse of the app. And I'll just give you the big picture of what this all means and how streamlined and simple this is, and it'll allow us to be more productive, ship things faster, and all of this will be backed by test. So we will be shipping with confidence in that we won't be breaking things when we ship. So let's jump right in. All right, so high-level overview. We'll be focusing on the iOS app because my background is in, I've spent like the last decade doing consumer-facing apps. For anywhere from like small startup phase to large, enterprise apps. A few of them are still in the App Store. Some of them are multi-billion-dollar companies, and I'm just sharing with you everything that I learned along the way without all of the struggles and heartache that it took to get here. So high level is that we want to have like a modular architecture such that it is fully scalable, fully maintainable, and fully under test, such that when we ship with confidence, and we know that things don't break in production. And this also sets us up for success when we want to consider other platforms such as watchOS, tvOS, visionOS, macOS. The idea here is that we're going to focus a lot of our effort in the foundation of the app, which is the core framework, and that has all of our business logic, all of our domain modeling, all of our services, networking, any Bluetooth communication tools, all of that exists within the core framework and module. Whereas with the other platforms such as iOS, watchOS, tvOS, we have them separated in the sense that it's a different concern. It's purely presentation layer. So the only thing we're thinking about in these layers is the views and how it uses the core framework to display the different app state that the framework or module is in. So when the user opens the app, like it will just reference the core. Okay, where should I be? What should I show the user? When the user takes an action in the presentation model, whether that's TV, macOS, watchOS, how should the core respond to that? So this is essentially the engine that powers our presentation and our views. So at a high level, all we're doing is focusing almost 95% of our effort into the core module, and these other platforms, they're just there to just show the state, to just show the view, and to handle any user interactions. So this took a really long time for me to wrap my head around because I was always just throwing everything in one place, and it was just a big mess. So when things broke, it was really hard to figure out how to detangle the web of like dependencies, all the different concerns. But with this module or this framework in mind, this mental model rather, it's simple to see like, okay, all of our effort will be in this engine that powers the app, and the view is just an extension of that. It uses the core to render and show things to the user and also accept user interaction. Okay, so now let's take a deeper dive into the core architecture. And what I'm going to do here too is I'm going to go back and forth between the architecture diagrams and the code, so you can kind of like see a one-to-one mapping of what I'm talking about and seeing it in practice. so it all makes sense to you. So as you can imagine, a lot of our domain modeling, our business logic, all of our tools and features that we're building will be in this core architecture framework. And it sounds like it's a daunting thing, but in reality, it's pretty straightforward and simple. We have our shared models that get used across all of these different layers, whether it's networking, features, and all of our dependencies are set up in our app core. Our networking layer that has to do with, our API, and potentially Bluetooth if we're doing any hardware stuff. And our features is as it sounds like. We're just going to be creating features in a modular way such that it has a clear reason to exist, and all of our dependencies are pretty straightforward. So let's take a look at our core architecture at a high level. So I'm going to go to Xcode. All right, so I'm going to show you what the app looks like. So once again, I've shared with you that we have that broken down into two steps. So we have the iOS app and the core. So if we go back to this portion here, the core and the iOS, that is what this separation is. So we have like our iOS app, which is purely focused on the views of our iOS app, and the core, which has like all of the business logic, domain logic of our app. So let's look at the core architecture. So I like to break them down into sources and tests. So our sources will be the different modules that I just shared with you. So this is your shared models, your networking, your features, and your app core. Your shared models will be where all of your domain models exist. So it's pretty straightforward, just like our domain modeling, any enums that we are using to represent objects in our app. The app that I'm demoing here is like this small inventory app. The idea here is that we're just going to account for different items, and we're going to store them in our app. And we're also going to be capturing receipts. The idea for this app was just that, my wife and I were recently displaced due to an apartment fire nearby, and we're just doing this inventory for our insurance company. So I was like, hey, this would be a great app for me to do this demo on. So all of our domain models exist in this shared models feature. So it's really simple. It's just like holding all of the classes or the structs that will be used throughout the app. They're also going to be sharing enums to be used, but once again, pretty straightforward is the shared models. So what I like to do is in my architecture, I want to make sure it's set up for testability. So for domain modeling, you don't necessarily need to do test. It's a little overkill in most cases, but if you have like any functions on your structs or your domain classes, I would highly recommend writing tests for your shared models. And I'll show you what this looks like in a second. Okay, so I have my sources and I have my shared models. So as we saw, we've got our structs and classes, and we'll just go to like our test feature here and go to shared model test. I don't have anything here. This is boilerplate, but this is where it would go if we had any shared models test. And this is all done within like the Swift package manager. This is like a clean way to separate concerns through large scalable apps. I like to place all of my core modules in this like Swift package to make things simpler, especially when I want to reuse this across different projects. And once again, this makes it really easy in the future if I ever want to use like any AI coding assistants to help me figure out how to be more productive, how to like quickly read what's going on, quickly find any bugs. Right now I like to use a combination of Xcode, Cursor, and Claude Code to get my work done and ship fast. But this is just one example of how it's done. I'm just sharing with you what works for me and how I ship apps very quickly without any issues and little to no bugs in production. Okay, I'm gonna keep going. So shared model test, and just to reiterate, that is one module within our core architecture module, and that can be reused across different domains. All right, so now let's take a look at networking. Similar concept, we have a framework just for networking, and we also have a framework for our networking test. Our networking at a high level is in charge of our API service, and it will also contain, enums that describe any errors that we may see or expect to see throughout our app's lifetime or life cycle. And, some examples of what the client could look like if our API service is using a client to make any API calls is that it could be like a super-based client where we're using like a third-party SDK of that sort and using that to make API endpoint calls. We could have our own custom-built HTTP client where we might be using like an explicit REST API endpoint to make calls to get data or make any changes. And we also could be seeing like an Apollo client. So if the backend is using any a graph mechanism to pull and update data, you could see Apollo client being used as well. So let's go ahead and show what this looks like in practice. So we have our networking layer here. We have our enums describing our errors. We have our API service. You could set it up however you want. It's just like high level what this could look like. I use like the handler pattern, and I'm also using a super-based client to grab and update data on the back end. So this is like a live implementation. I have my API service set up where it uses a super-based client to make any changes and fetch any data. And then all of this is driven through test-driven development, TDD, where basically I write failing test first for all of my modules. And a lot of this, I kind of give a description on an example of how I would like it written. And, I can use coding agents such as Cursor or Cloud Code to catch any of my blind spots or to just use the same patterns that I've been using throughout my, decade of experience. And it's able to spin out some tests that fail, and I write code to make those tests pass. And I feel pretty confident about shipping when, I have passing tests every time I make a change. So it's pretty straightforward when I want to test this. So if I go to networking test module, given that this is the beauty of having this core module is that given that I am only testing the networking module, I can just quickly run my test, change my scheme to networking test, and I can test it on a Mac. It doesn't matter because it's framework independent. My test will quickly build because it's not depending on so many dependencies. And when it runs, hopefully these pass, they better pass. Give it a second here. And they pass. So, like I said, it's pretty streamlined, and using test-driven development makes it pretty simple to move with speed and move with confidence and keep any coding agent from breaking things. All my tests pass. And I can do the same for any of these different test modules, but we'll get to that later. Okay, so I'm going to keep going. That's the networking module in my architecture. And taking a step back, we're still within the core architecture domain, and we just looked at the networking, and we previously looked at shared models. And don't worry about taking any notes here. I'm going to share this diagram for you all, so you have an idea of like how I think about architecture. And if you have any questions that are coming up, feel free to leave them in the comment section, and I'll get to them as soon as possible. My vision here is that I would like to have a community where I can share all of my knowledge and share all of my code and give you all give you all of the benefits of what I've learned without any of the scars. And yeah, I would love to have you join this community. I don't know if it'll be built by the time I release this video, but take a look for the description. Keep a lookout for the community in the description of my videos. All right, I'm gonna keep going. All right, let's now look at how I set up features. All right, so typically when I wanna build a new feature, once again, I start with the test. I'll write out the test, but this is typically the structure of how it looks. So like I said, we're building an inventory app right now. So one of the features would be the inventory, right? So I would set up the feature within my features module, and it'll have these main domains. It'll have like a navigation, it'll have view models, it'll have services, and it'll have this public facing feature file that other dependencies can call and focus on, whereas these entities here, they'll be private, so you can't really touch the stuff. It makes it like there's a guardrail there that myself and future developers, any AI coding assistants will know that it only needs to focus on this public-facing feature file to make any changes and to make any API calls and to observe any state changes. I like to use the router pattern for navigation so that the router holds the state of which the app should be and where the app should be navigated to, as opposed to keeping any state or logic in my views. I want my views to be logic independent, like very, the presentation shouldn't hold any state, essentially. It should be expressing the state of the view model. Like it should be, the state should be driven from the view model, not the view. And I think in my years of development, I saw this like pretty bad pattern of developers trying to like keep and maintain state within the view, and that view could like change over time if a user grabs a call or like kills the app. Like there's so many things that could go wrong with trying to like maintain the state of the view within the view. So it just makes sense to like abstract all of that plumbing and logic into this feature module, and we'll take a look at that and how that's set up in a second. But high level, I use TDD to write my test. Most of the times I write that manually, but once I write enough of those tests, I can send it off to an AI coding assistant for a future feature to say, hey, reference this past feature that I made, use the same pattern to write test and to write out the feature, and it works like a charm. We sometimes need to import shared models and networking for services that may exist within the feature. So you'll see some imports there as well. And all this is still within our core architecture Swift package. So let's take a look at that. Let's look at the inventory feature. Okay, features, inventory. All right, so like I said, we have navigation, we have services, we have view models, and we have our public-facing feature. The public-facing feature will be the one that is able to be used outside of this domain within our dependency container. We'll take a look at that later. But here's where it initializes everything from our services to our router. Let's look at navigation. With our router, we're able to share different destinations on different states that the app could be in. So if I want to add an item to this screen, a destination could be add item, and then that'll tell the system to present the add item sheet. Another destination could be present the filters sheet, and we'll call that destination filters. And essentially the router will hold the state in which the view should react to. So the router will be like this observable object, and as you see that observable keyword here, the router will be the observable object, and the view will react in the sense it'll be binded to the router. And whenever the router changes, because the view is observing the router, the view will make some state change, and you'll see the view change based on these observable states, such as the router and the view model. So as you can see here, All of our view models are observable. They hold state. They also handle any computation, any changes, business logic. And for services, we just use the networking layer that we created earlier. So as you can see, handles networking. We're using the Supabase client. Yeah, all straightforward. And we can show the same for receipts, or public-facing receipts feature. We have our view models for every object that we want to, or we have the view models for most of the actions that we want to take, services for any endpoints we want to make, any calls, and same for routers and destinations, same idea, same pattern. Okay, so that is the features module. Now we're going to take a look at the features test. So inventory feature test. Yeah, essentially it's just like, hey, create this feature with all of these different dependencies and run test. Let's see if I can quickly show the test here. Receipts feature. Now let's add this test here so I can show you the working test. Inventory features test. Okay. So if I just want to quickly run the features test, keep in mind it's independent of frameworks. So I'll run it on my Mac and they pass. So it's pretty nice to have independent modular frameworks being isolated. So I can test that isolated framework very quickly. If anything is broken, I know exactly where I need to go. I can ask Xcode, Cursor, Cloud Code, like, hey, test every single module and make sure they pass. And it's able to quickly do that in isolation. So it allows me to continue to be productive and know exactly where things may break when I make changes and to quickly update them so they're passing. So you can imagine at like a large company or a large code base, this makes it really streamlined to keep moving at speed and move very quickly. Okay, so let's go back to our high-level architecture diagram here. So that was features. Once again, if you have any questions, leave them in the comments, and look out for any communities that I might build in the future where I can maybe get on a live Q&A and answer any of these questions with good examples. All right, and last but not least, the app core. So this is basically where we will compose all of our apps dependencies into a single container, and that container will be dropped into different frameworks such as iOS, visionOS, tvOS, etc. So we'll have our dependency container where we initialize all of the features, all of the networking, all of the shared models if needed, and it'll hold all of the features that are used throughout the app. So feature. So imagine 10 of these, they'll all be contained within the dependency container. And yeah, we just need to initialize that networking framework, whether that's Bluetooth hardware, Supabase client, HTTP client, etc. And identical to previous modules, everything is test driven. So we write the test before we write the code, and everything is tested and created in isolation. So when I want to run my test and make any changes, I can just quickly do that in Xcode. Secrets file to make sure we don't upload this to GitHub, and that holds all of our API keys. Yeah, keep them secret, and we put those in the git ignore. All right, so let's show you what the app core looks like. So our dependency container, this is where we initialize everything. So we configure the Supabase keys, the routers. So we have a router for the inventory, router for the receipts, all the services. And we have our facades, our feature facades. Essentially, this is like the public-facing feature that will be used throughout the app's life cycle. But these services are private, so they're just used to create the features. So the inventory, receipts if you can imagine in the future, it might be the settings, authentication, etc. It's all initialized in the dependency container, and yeah, it's really clean. So I have everything just like dependency injected, so we can make this like very testable. So let's take a look at the test, app core test. So once again, we have test in isolation just for our app core module. Let's see if I can just quickly show that really quick. I'm gonna make a test target for app core test. Okay, done. And now we're just gonna run these tests in isolation. And like I said, it's so quick. It's framework independent, so running on my Mac, test pass. Okay, so going back out to our architecture, what we have here is we've looked at the whole core architecture package now. We've looked at shared models, we've looked at our networking, we've looked at several features, and we've looked at the app core that will be the entry point into all of these different modules. And everything is test driven. Everything is written in isolation, and it's super modular, so we can place them in any platform that we want. But for the purposes of my app, I'm only going to be focusing on iOS for now. Okay, so we've done that. We've looked at app core. So now we're going to look at the iOS app specifically and show you how the core is used with the views for the UI portion. So let's go back to our app. So once again, this was like the core package that we looked at. Now we're gonna look at the iOS app, and this might blow your mind, but it's so simple. I have little to any files in this area. There's only, our default function here, where our default workspace, where it's like, it gives you those template folders where it's like iOS app test, iOS app unit test or UI test. And we're only going to focus on the iOS app because that's where we're just like adding in our core package. So if you look at the entry point here, this is like the entry point. My naming's a little messed up here because I called the workspace iOS app, so it added an app to it automatically, but typically it would just say app. Yeah, this is it. It's super simple. We're just importing app core. We are observing the dependency containers live instance, and we have a main tab view with the environment object using container. So if you remember from the dependency container, let's just open this up. This is like our entry point to all of our services, all of our frameworks, and we're only going to be focused on our public features. So inventory, receipts, initializer, and our live instance. There's also a mock instance or a preview instance for any previews that we'll have in our views, and we'll take a look at that in a second. But yeah, this is how simple it is. I just have an app entry point. I import my app core. That's it. And all of the views are just relevant to my iOS app. So if I had like different platforms like watchOS, tvOS, whatever those views look like, it'll be specific to that platform. So for here, we're just focusing on the views for the iOS app. So let's take a look at the main tab. Actually, not sure if the preview is going to work, but we'll see what happens. Essentially, the container gets used here. We know that we're going to be using the inventory feature and the receipts feature. We'll have the tab view with the item list view being passed into the view model, or the view model being passed into the list view. That view model will just get from the container. Router will get from the container. View model for the receipt list view will get from the container. Router will get from the container. So everything is just like contained within the container, which makes sense. Yeah, it's pretty straightforward. And I think all this came from, the simplicity of breaking things down into their specific use case. And having those fully tested gave us confidence that when we send them to our views, everything works as expected. And all of that all of those expectations are written explicitly in our test. So when I run the app, let's just run it real quick. I can choose the platform, which will be iOS. So this one will be iOS 16. So it's running. And also it makes the build process a lot smoother too, because all of our code now is relevant or specifically written in the package. It only needs to recompile when we make changes to the packages. But given that we're not making changes to the packages, the build times are like exponentially faster. So now I can quickly run my app, see all of my views pretty quickly, and yeah, it's pretty neat, pretty fast. Let's go back to the app. Yeah, so that's iOS app. That's it. And big picture is, in the future, I could demo like tvOS using the same pattern, visionOS using the same pattern, watchOS, macOS, it doesn't matter. All I need to do then is to just create the views to represent different states that my core package represents. And whenever the UI is built for each of these platforms, it just needs to observe any changes to different frameworks that are written explicitly in the core package, just like we did for the iOS app. And all we do is we drop in the core into that platform, and we just build our views. And it's pretty straightforward, pretty simple. So that's how I build apps, and that's how I would build them at scale for small stage startups, prototypes, but also for multi-billion-dollar apps that depend on scalability, testability, and uptime. So if anything goes wrong, we need to be able to respond through incident response very quickly and be able to debug very quickly. I would feel confident with this architecture in order to do that at scale. So that's all I have for you all. If you enjoyed this, please leave a comment, feel free to follow, and please look out for the community where I'm going to be sharing all these tips for free, where you can ask me questions. And yeah, just excited to share with you all what I've built and what it took me so long to figure out over this decade of learning iOS development the hard way. All right, take care.